Good day and mabuhay. I am Brian Lara of 10 Lawrence here to discuss the topic, the end behavior of polynomial functions, to serve as my STM first quarter project. So let us first define what is end behavior. Well, end behavior is the behavior of the graph as x reaches positive infinity and negative infinity. This is best represented as x reaches positive infinity to serve as the end behavior of the graph on the right side, and x reaches negative infinity to serve as the end behavior of the graph on the left side. Always do remember that the x-axis is the horizontal line on the graph and not the vertical line. So let's start with determining the end behavior of a graph with an even degree. The easy way to determine if a graph is in an even or a negative degree or an odd degree, is if the arrows are pointing in the same direction. With an even degree, you have the arrows pointing in the same direction, and with an odd degree, you have the arrows pointing in opposite directions. So, to the example on our left, the leading coefficient is positive, and an easy way to determine if the leading coefficient is negative or positive is with the right side of the graph. If the right side is facing up, then the leading coefficient is positive, and if the right side is facing down, as seen on the right example, then the leading coefficient is negative. So for an even degree graph with a leading coefficient that is positive, the end behavior is f of x reaches positive infinity as x reaches negative infinity, and f of x reaches positive infinity as x reaches positive infinity. And for the end behavior of a graph with a leading coefficient that is negative in the even degree, f of x reaches negative infinity as x reaches negative infinity, and f of x reaches negative infinity as x reaches positive infinity. So we could notice in both of the graphs, let's start with the left side, f of x reaches positive infinity as x reaches negative infinity. If we look at the left side of the graph, the arrow is still pointing up even if it is on the negative x-axis. So that is why we came up with f of x positive infinity as x reaches negative infinity. And you just have to apply that same logic to the graph on the right side with the positive infinity. So an end behavior of a graph with an odd degree. Again, it is an odd degree if the two arrows are pointing in opposite directions. So for a graph with a leading coefficient that is positive, we have the end behavior f of x reaches positive infinity as x reaches positive infinity because the right arrow is pointing up, and f of x reaches negative infinity as x reaches negative infinity because the arrow on the left is pointing down. And for a leading coefficient that is negative, we have the end behavior f of x reaches positive infinity as x reaches negative infinity, and f of x reaches negative infinity as x reaches positive infinity because the arrow on the right is facing downwards and the arrow on the left is facing upwards. So, before going further into the topic, let us first define another important term in the topic of end behavior, which is zeros. So what are zeros of a polynomial function? Well, these are values of x that will make the function equal to 0. Or in other words, these are the x-intercepts of the graph. And if it isn't obvious by now, x-intercepts are points in the graph where the graph touches the x-axis. So we could say in this graph over here, the degree is odd because the arrows are pointing in opposite directions. The leading coefficient is negative because the right arrow is pointing downwards. And so we could say that the end behavior is f of x reaches positive infinity as x reaches negative infinity, and f of x reaches negative infinity as x reaches positive infinity. And as we could see on the graph, that the x-axis is intercepted, that the graph moves through the x-axis 3 times, seen on the graph. So we could say that there are 3 zeros on the graph. And for this next example, we have a graph with a degree that is even and the leading coefficient that is negative because again, the arrow on the right is pointing downwards, and so we have the end behavior f of x reaches negative infinity as x reaches negative infinity, and f of x is negative infinity as x reaches positive infinity, with still three zeros because the x-axis is intercepted, or the graph moves through the x-axis three times as seen in the picture. So for another example, we have a graph with a degree that is odd, a leading coefficient that is positive this time because the right arrow is pointing upwards. So we have the end behavior f of x reaches negative infinity as x reaches negative infinity, and f of x is reaches positive infinity as x reaches positive infinity. And again, we still have three zeros because the graph moves through the x-axis three times. And for the last example, we have a graph with a degree that is even because the two arrows are pointing in the same direction, and with a leading coefficient that is positive this time because the right arrow again is pointing upwards. So we have the end behavior f of x reaches positive infinity as x reaches negative infinity, and f of x reaches positive infinity as x reaches positive infinity. And this time we have four zeros because the graph moves through the x-axis four times as seen on the picture on the left. And that is all for this topic. A very, very great thing about this topic is how you do not need specific values on the graph to be able to determine the end behavior of the graph. And that's what makes this topic very easy. And thank you for listening.